Welcome to Trust the Process. In this video, we're going to conclude story sheet 1 by answering the last part of question 3. So the question is saying, the same load is hung from a second wire of the same material. This wire is twice the length, but the same volume as the first wire. State and explain how the extension of the second wire compares with that of the first. So what the question here is saying is, we have two wires. We have the first wire and second wire, like that. So we have the length of the first wire to be L1. This is the original length. We are going to have the area of the first wire to be A1. We are also going to have the extension of the first wire to be changing L1. The force that is exerted on the first wire to be F1. The Young modulus of the first wire to be Y1. And the volume to be V1. This is what we have. Then for the second wire, we are going to have the same thing. We are going to have L2 representing the original length of the second wire, A1 the cross-sectional area, A2 the cross-sectional area of the second wire, changing L2 the extension in the second wire. Then the F2 will be the force exerted on the second wire. Y2 is going to be the Young modulus of the second wire, and V2 will be the volume of the second wire. Now, according to the question, let's see what we have for A2 in comparison with A1. So they are saying the same load is hung from the second wire of the same material. So we have got two things to note here. The same load, meaning the force is the same. And the same material, here the same material, meaning we are dealing with the same Young modulus. That's what this means. The same force and the same what? Material. Alright, so what we know about the second wire is this F2 is just going to be equal to F1, Y2 will be equal to Y1. And then they are also telling us to say this wire is twice the length of the first wire, meaning L2 is equal to 2 L1. Okay? And then the question is saying, before the question, they are also saying, but the same volume. So this wire has the same volume as the first, so the volume is the same, as we can see from that statement there. Now, how do you compare the extension? So we are looking for the extension of the second wire. How do you compare the extension of the second wire to that of the first wire? So nothing has been mentioned in terms of the area for both wires. Now, how do you find the area? We know that, or volume. How can you find the volume of the wire? A wire is going to be cylindrical, so the volume of a wire generally is going to be the area multiplied by the length. So for V1, the volume for the first wire, it will be area for the first wire multiplied by the length for the first wire. The volume for the second wire should be the area for the second wire multiplied by the length for the second wire. But what is it that you know about the length for the second wire? The length for the second wire is twice the length for the first wire, meaning the volume of the second wire is 2 area for the second wire, the length for the first wire. And clearly they are saying that the volume for the first and the volume for the second are the same. So here A1 L1 should be equal to 2 A2 L1. Making A2 subject of the formula, this and that can cancel. You have the area of the second wire, which is going to be which is going to be the area of the first wire divided by 2. So clearly from this expression you can tell that the area of the second wire is going to be, the cross-sectional area by the way, it's just going to be half that of the first wire. So if the first wire is like this, if this is the first wire, that is going to be the second wire. The second wire is going to be very, very thin, and it will be longer than the first wire. That's what they mean. So for these two wires to be of the same volume, it means this one has got a bigger cross-sectional area than that one. This is making sense. Alright, now how do you find the, because here we've been told, so we know another thing, we know that the area of the second wire is just half the area of the first wire. Now how do you find the change in L for the first wire? The change in L for the first wire are just combined in the stress and the strain. You know that A over the, you know that the force here, the force that is exerted on an object, F over A is equal to the Young modulus, then change in L over L naught. So for the first wire, this is L1, so L1 for the first wire, or change in L1 can be found by F L1, these are ones, for the first wire, over A1 multiplied by the Young modulus. Okay, then for the second wire, you know that it's going to be change in L2 will be equal to F2 L2 over A2 the Young modulus. Now this F is the same, so you can just say F1 because it's the same as the F1, so you can also put 1 there, put 2 there. Then L2, the length of the second wire is twice the length of the first wire, over the area of the second wire is the half the area of the first wire. Then the Young modulus of the second wire is just the same as the Young modulus of the first wire because they are made of the same material. So here you are going to have 2 F1 L1 over A1 Y1 over 2. So this is going to be 4 F1 L1 over A1 Y1. So the change in Y, the extension in the second wire is just going to be 4. When you see this, look at this. This is nothing but the extension in the first wire. This is that. So this is just the extension in the first wire. So from here you can tell you have stated what the question wants. The question wants you to first start by stating you've stated that. So the comment that you can make here is the extension in the second wire. The extension in the second wire is just going to be 4 times the extension in the first wire. The extension in the second wire is just going to be 4 times the extension in the what? First wire. So in short, the extension in the second wire will be the extension in the first wire has to be quadrupled for you to find the extension in the second wire. This is what this statement means. So change in L2 is equal to 4 change in L1, meaning the extension in the second wire is 4 times the extension in the first wire. Okay, that's it. So you can also try out to solve what would happen if the first wire is as it is, but the second wire, the statement in the second wire, the same way this question is. Just try to maneuver around it. You can say, instead of having twice the length, let's say the length of the second wire has been halved. So if the length of the second wire has been halved, what is it that you're going to have? If the length of the second wire is halved, meaning it is half that of the first wire. If the length of the second wire is half that of the first wire, see what is going to happen to the extension and make a conclusion. Thank you so much, and let's keep on studying. Let's make sure that we study, we go through as many concepts as possible. And if anything, if you don't understand the concept, feel free to comment. You can ask the question in the comment section, or you can email me that question. I will be able to respond. Thank you so much. God bless.